How you doing, everyone? Greetings and welcome to episode 8 of Learning bAtari Basics. So what we're going to do today is we're going to do extra stuff that I hadn't really intended on doing because this was supposed to be the very last episode. And that's what I said to you in episode 7 as well. But as it turns out, going through the list of stuff that I hadn't covered, I noticed there was kind of two things that were very useful and kind of merited an episode of their own, so I said I'd throw one together on them. So what we're going to do today is we're going to have a little look at using conditional logic in if-then statements, and we're also going to have a look at breaking up variables into individual bits so that we can use them a little more efficiently. So just to kind of lead in to what this whole conditional logic thing is, any of the programs that we've written up until now, we've used if-then statements. Now, we'll continue using those as well, but they've been very simple kind of if-then statements, whereas if the fire button is pressed, then fire a gun type thing. With conditional logic, we can, well, they become a little more powerful in a way. We can kind of set conditions a little more. For example, if you had a game where you had a guy running around looking for a gun, there's no point in making that gun fire until he's found that gun. So in that case, you would have like, if the guy has found a gun and if fire is pressed, then make him shoot, that kind of way. So that's the kind of stuff we're looking at. So what we'll start with is a little example program I've written to show you the or type thing that we can throw in. So if a condition is met or another condition is met, then do a thing. And what I've done is written a little Bob program again, as I usually do for these. And we're just setting a couple of variables up for our XY position, for the color of our sprite, and also for a little counter so that he'll animate as well. And we are setting up our Bob sprites and going down through our joystick control and whatnot. Nothing that we haven't covered before. However, the one little extra thing I've thrown in here is I've got if joy fire. Now normally we would do if joy 0 fire, then C equals C plus 1. And that'd be our Bob flash if you pressed fire. But what I have going here is if joy fire, and then I have these two little vertical lines, which means or. Now, what these vertical lines are called, I'm not 100% sure. Back in the days of DOS, back in the early 90s when I was using DOS and stuff, we used to call those pipes when we were using the more command. But I don't know if that's what they're called or not. But anyway, they're these little vertical lines. Two of those gives us our or statement. So what we have here is if joy 0 fire, or if the value of x is greater than 80, so if Bob is over kind of on the right hand side of the screen, then C equals C plus 1, then Bob will start flashing. So that's what we have going here. And if I run that program just to show you, it starts off with Bob on screen here. Now we can move him around as we did before. If I press fire, Bob will start flashing. That's what we told it to do. But the other part of it was, or if Bob is beyond 80, so if he's over on the right hand side of the screen, he starts flashing as well. So that is how we can kind of use an if-then statement a little more effectively, I suppose. And also we can save ROM space, because another way of doing that, you could do two individual if-then statements. If joy 0 fire, make your man flash, or if he's beyond 80, make him flash as well. But you'd be using up more ROM space and your program would run slower. And this way is more efficient and lets it run a little bit better for us. Now, the other option that we can use is with the AND statement. So it's exactly the same thing as I showed you before here, exactly the same program. But the difference is, instead of the two vertical bars, which mean or, we've got two little ampherands here, which mean and. So I've got if joy 0 fire and x is greater than 80, then make him flash. So in this situation, he won't flash until those two conditions are met. I can press fire to my heart's content. If he's not over on the right hand side of the screen, he won't flash. And equally, he can stay on the right hand side of the screen as long as fire isn't pressed, he will not flash. That's pretty much the way this program, or this particular line, will make the program work. So running that, I can show you exactly what that is. We've got Bob here. He's moving around as he did before. Over on the right hand side of the screen, he ain't flashing until I press fire. But If I move him over to the left-hand side of the screen, now his X value is less than 80. When I press fire, he doesn't flash at all. So he'll only flash as long as those two conditions are met. He's beyond 80 and we're pressing fire. And like I said before, that could be used in a game where a little guy is looking for a gun, and until he finds that gun, your fire button is ineffective. And that's pretty much how you can use those. So it saves us ROM space, it makes the program a little faster, and it's very easy use. So really, it's a fantastic little thing to know about. Okay, so the second thing I'd like to talk to you about is economizing variables in bAtari Basic, because bAtari only gives us 26 variables. They're labeled between A and Z. And once they're used up in a program, they're kind of used up in the program. Generally, we've been using variables to store X positions, Y positions, and all that kind of stuff on screen. And that's how they should be used. But there are times when you can get kind of clever with them and economize them a little bit. And the way it works is this. A variable is capable of storing a number between 0 and 255 because it is an 8-bit variable in bAtari Basic. Now, if you take that variable and you rip it asunder, what you'll find in there looking at you are 8 little bits. So 8 little segments that can either be a 0 or a 1. And that's the way the variable remembers what number it's holding. It's binary counting, more or less. So what we can do is, if we are using a variable for a value that's binary, more or less it's either on or off, you know, does the guy have the gun or does the guy not have the gun, we can in fact stick that value into what I would coin as a mini variable. So what we're going to do is, you would take your variable, rip it asunder, and inside of it you would have your 8 bits. So labeled from bit 0 to 7, because this stuff likes to be complicated. But what you can do is you can use each of those bits to store that type of information. Does he have the gun? He does, then the bit is 1. If he doesn't, the bit is 0. Is he at the top of the screen? Yes, he is. The bit is 1. If he's not, the bit is 0. And what we're doing all of a sudden is, for any of these binary values, we can pretty much use this variable to store up to 8 individual separate pieces of information, if that makes sense. So again, if you are storing a value that is like 0, 1, or 2, you've got to use an entire variable. If you're storing a value that's 0 or 1 and nothing else, you can use a bit. So what you can do is, for example, take the C variable and put that aside to store 8 binary pieces of information, if you like. If that makes any sense. This stuff is difficult to explain. But anyway, let me show you in this little program that I've written here. What we're going to do is, I've got a program that'll put Bob on screen, and if he moves to the right, he'll stay facing to the right. If he moves to the left, he'll stay facing to the left. And in order to show it to you, what I've done is I've taken the C variable, ripped it asunder, taken its first bit, and I'm using that to figure out what way he's facing and what to do. So the program is written pretty much the same way as we would write any programs. We've got our A, X, and Y variable equaling something. What I've done here is the C variable. You'll notice there is a 0 in chain brackets. And that's because what I'm saying is, rip the C variable asunder, take the very first bit inside of it, so 0 being the first bit, and turn it off. So assign the value of 0 to it. Now remember, it's just a bit, so it can be either 0 or 1. It can't be anything else. And when we move down through the program here, I've got conditions set up for the joy 0 right and the joy 0 left. So joy 0 right will move Bob across the screen. As we see here, it'll also increment the animation counter. But the other thing it'll do is it'll take bit 0 of the C variable and it'll turn it on. It'll stick the value of 1 into it. If we move to the left, it does the opposite. It takes bit 0 of the C variable and it turns it off. It sticks the value of 0 into it. And we see down here further, which changes a little bit as well, but we're dealing with bits, so it kind of makes sense. Before, what we had was likes of if c equals 0, then do something. If c equals 1, then do something. If c equals 100, do something else. Here, because we're dealing with bits, it's either 0 or 1. The way they've set it up is if c, 0 in chain brackets, that means if it is turned on, if it equals 1. That's all. If you write it down just like that, it means it equals 1. Then our ref p0, which is the command to reflect our player 0, will equal 8. So that'll turn it on. We covered that in an episode previous. Now, if the first bit in C equals 0, so if it's turned off, then the ref p0 will equal 0. And you'll notice here, in order to show that it equals 0 or that it's turned off, they've put a little exclamation mark in front of it. So basically what it means is this. If you write down the variable with the chain brackets thing, that means it equals a 1. And this guy here, the exclamation mark, means not. So if it's not on, if this is on, then do that. If this is not on, then do this. That's as good as I can explain it to you. But you can actually set up the C variable in this instance with a 0 in the chain brackets, a 1, a 2, a 3, a 4, a 5, a 6, or a 7. And you will get kind of 7 binary variables from that one variable, that kind of way. So you can save variables that way, which is good to know and can come in very, very handy. But when we run that little program there, what we should get is we should get a Bob that when he moves in a direction, he stays facing that direction. So that's pretty much what we're doing, just using 1/8 of a variable pretty much to store that information. So it can come in very, very handy. But there you go. That's it for this episode. We're going to have the very last episode come out very, very soon because I'm going to start recording it right now. And until then, and hopefully maybe even the day you watch this, I will say to you bye-bye, and we'll talk to you very, very soon. See ya.